Hi class, let's talk about the movement about exercise X from today's lecture. So here is an example. We have the force vector F, and we would like to know what's the force movement on X. So to solve this problem, we can first use the cross product between the D and force F, which will be the direction from point O to the force and its cross product of the force vector. So it can be the point can be any point on the x-axis. Okay, so after the calculation about cross product between a D and F, we can get a moment MO, which is in this direction, and then we need to find the moment MOs, okay, its component perpendicular to x-axis, okay, which is my. So by this way, we can calculate the force movement on 1x. Okay, so let's see, we already get MO, and the my will be MO times cosine theta. Okay, that's one method. Another method is we can just write my as F times dy. Okay, dy is a perpendicular distance from the first vector to the perpendicular direction of the x. So how to calculate the dy? It will be F times by d times by cosine theta. Okay. Okay, another way of calculate movement about x is we use a vector analysis. So for example, the MO will be R cross product of the F. So it will be the my will be the component my along the y-axis is a projection of MO onto the y-axis. So it can be found using a dot product, okay, as we discussed before. So which means my will be G dot MO, which become G dot R cross F. Okay, so G is the unit vector of y axis. So we can also generalize this approach by letting the G vector to be the any unit vector that specify the direction of the a-axis. Okay, so the equation will be A could be MA will be unit A dot R cross F. The MA will be unit AX plus AZK dot IGK RX RY RZ fx, fy, fz. So equation will become ax, ry, fz minus rz, fy minus uay, rx, fz minus rz, fx plus uaz, rx, fy minus ry, fx. Okay, that's the equation. And we can also write this equation in the form of the determinant. So mi will be ua dot r cross f. It will become uax, uay, uaz, rx, ry, rz, fx, fy, and fz. Okay, and the uax, uay, uaz represents x, y, z components of the unit vector, defining the direction of the ax. So the a could be any x. Rx, ry, rz represent the xyz component of the position vector from any point O on the ax, okay, to any point A on the line of action of the force. And x, fy, and fz represent xyz components of the force vector. Let's see an example. So a force is applied to the tube. So the magnitude of the moment of force about the x. So what will be the magnitude of moment of the force about the x-axis? So how to solve this problem? As we discussed before, we can use the equation. Okay, mz equals to u dot r cross f. First, we need to find the f's in the cartesian vector form, and u in this case will be 1i in this case, because u is a unit vector of the x. And the vector r is a position vector from O to A. Okay, let's continue. We know u is 1i, and ROA, the direction vector from O to A, will be 0i plus 0.3g plus 0.25k. The unit is meter. And the f, okay, you can do the decomponent of the f, which will be 200 times cosine 120 in the x direction, plus cosine 60 in the g direction, and cosine 45, okay, in the k direction. So here is the answer of the f. And then you can use the equation. Okay, the equation we already discussed here. Equation will be mz equals to u dot roa cross f, which will be this determinant. After you solve this determinant, you can find mz equals to 17.5 Newton meter in counterclockwise direction. Okay. Let's see another example. The force of the F equals to 30 acts on the bracket. Alpha is 60, beta is also 60, gamma is 45. So what's the moment of the F about the AAX? So the O, we can define the point O, okay, is our 0, 0, 0 point, the O. So our plan is to let's find the UA and ROA first, and find the M in Cartesian spectral form, and then use this equation. So what's UA? For this problem, we want to find the F's movement about AAX. So the AAX, in other words, should be, because X is this direction, Z is this direction, the AA should be the Y direction, okay? Because AA is perpendicular to XZ plane. So the UA will be just G, and ROA will become minus 0.1 G, I plus 0.15 K in meter. And F, okay, you already know the alpha, beta, and the gamma angle. You can decomponent F into X, Y, Z, all in the Cartesian form very easily, which is like F equals to 30 times cosine 60 plus cosine 60G plus cosine 45K. So that's the F. So we already get the unit vector, our direction vector ROA, and F vector. Let's use the determinant, write down the determinant, and let's solve it. So that's it. Okay. So that's pretty much for today's lecture.